अच्छा, दिस दिस पार्ट वो रिकैप ये कर लेते हैं। वो पहला हमने जो किया था वो एनर्जेटिक्स पे वो था कि बॉन्ड्स ब्रोकन माइनस बॉन्ड्स फॉर्म, ठीक है। एनर्जी नीडेड फॉर ब्रेकिंग बॉन्ड्स माइनस एनर्जी रिलीज फॉर फॉर्मिंग बॉन्ड्स। और उसके अंदर इशू ये था कि उसके लिए आप बॉन्ड एनर्जी यूज करते हो कि एक रिएक्शन में कितने बॉन्ड्स टूटे, कितने फॉर्म हुए। एंड द थिंग इज कि वो बॉन्ड एनर्जी जो डिफाइंड होती है वो डिफाइंड होती है इट्स एनर्जी नीडेड टू ब्रेक वन मोर बॉन्ड्स ऑफ द सेम टाइप इन गैसियस मॉलिक्यूल्स। तो वो सिर्फ गैसियस मॉलिक्यूल्स के लिए डिफाइंड होती है। तो इसलिए आप उसको हर जगह यूज नहीं कर सकते। इट्स ओनली यूज फॉर इफ द सब्सटेंसेज आर गैसियस, ठीक है। तो ये तो ओ लेवल्स का ही था। और फिर हमने डेफिनेशंस की थी। इंथैल्पी ऑफ कंबशन की, इंथैल्पी चेंज ऑफ फॉर्मेशन की, और हमने डेफिनेशन की थी इंथैल्पी चेंज ऑफ न्यूट्रलाइजेशन की। ये मैंने नोट्स उस पर ग्रुप पे पोस्ट भी कर दिए थे। तो अगला जो पार्ट है वो ये कि और इंथैल्पी चेंज ऑफ रिएक्शन भी किया था। अब आ जाते हैं उस पे हेस लॉ पे। तो हेस लॉ सिंपली स्टेट करता है कि, और ये पता होना चाहिए कि व्हाट डज इट स्टेट, ठीक है। ये आपको पता होना चाहिए। इट्स एनर्जी चेंज फॉर रिएक्शन इज द सेम नो मैटर व्हाट पाथ इज टेकन, ठीक है। तो अगर आप कार्बन और ऑक्सीजन को रिएक्ट करके यू फॉर्मिंग कार्बन डाइऑक्साइड, ठीक है, तो डायरेक्टली फाइंड आउट फॉर्म कर सकते हो। तो कार्बन डाइऑक्साइड बन जाएगा। तो उसमें क्या होगा कि दैट इज वन पाथ। उसकी एक पर्टिकुलर एनर्जी चेंज होगी। कुछ बॉन्ड्स तोड़े होंगे, कुछ बॉन्ड्स फॉर्म किए होंगे। तो वो जो भी एनर्जी उसकी नेट एनर्जी निकलेगी वो उसकी इंथैल्पी चेंज होगी। द अदर वे टू डू दिस इज कि आप उसको कंप्लीटली बर्न ना करो, उसको कार्बन मोनोऑक्साइड में कन्वर्ट कर लो। पार्शली उसको ऑक्सीडाइज करो। और फिर वो कार्बन मोनोऑक्साइड इज फर्दर रिएक्टेड विद ऑक्सीजन एंड इट प्रोड्यूसेस कार्बन डाइऑक्साइड, ठीक है। सो दैट इज द सेकंड पाथ। सो दैट्स अनदर रूट कि आप उसको स्टेप्स में कर सकते हो। तो बट सिंस यू आर फॉर्मिंग कार्बन डाइऑक्साइड इवेंचुअली, तो ये दोनों पाथ्स जो हैं ये दोनों एग्जैक्टली इनकी इंथैल्पी चेंज, एनर्जी चेंज एग्जैक्टली सेम होगी, क्योंकि एट द एंड ऑफ द डे आपने वही बॉन्ड्स तोड़े होंगे, वही बॉन्ड्स ओवरऑल फॉर्म किए होंगे, ठीक है। तो द रिएक्शन कैन बी डन, ठीक है। हेस लॉ कहता है कि द रिएक्शन कैन बी डन इन स्टेप्स, ठीक है। इट कुड हैव मल्टीपल रूट्स। इसके अलावा कोई और पाथ भी हो सकता है, ठीक है। सो सो द आइडिया इज कि द एनर्जी चेंज ऑफ पाथ वन एंड पार्ट टू आर एग्जैक्टली द सेम, ठीक है। उसका मतलब है कि ये तीन रिएक्शंस हैं और ये साइकिल बनी हुई है। तो डेल्टा एच वन इज बेसिकली इक्वल टू डेल्टा एच टू प्लस डेल्टा एच थ्री, ठीक है। पाथ नंबर वन इज इक्वल टू पाथ नंबर टू एंड दैट गिव्स यू दिस रिलेशनशिप, ठीक है। इस रिलेशनशिप का फायदा ये है कि इट इट क्रिएट्स अ रिलेशनशिप बिटवीन इंथैल्पी चेंजेस। तो इन रिएक्शंस में से ना एक की भी इंथैल्पी चेंज इफ इट्स नॉट नोन, तो वो इंथैल्पी चेंज यू कैन फिगर आउट, ठीक है। कि अगर आपको ये पता है दिस इज नॉट नोन, तो आप फिगर आउट कर लोगे। अच्छा, हेस लॉ का मेन फायदा क्या है? उसका जो मेन फायदा ना वो ये कि देयर आर सर्टेन रिएक्शंस दैट आर वेरी डिफिकल्ट टू मेजर इन रियलिटी, ठीक है। वो कभी कभार इस तरह पूछ भी सकता है। फॉर एग्जाम्पल डेल्टा एच वन जो है ना, इसको आप कभी भी हेस लॉ से कैलकुलेट नहीं करोगे, क्योंकि कार्बन को लो, ऑक्सीजन में बर्न करो, कार्बन डाइऑक्साइड प्रोड्यूस होगा, कैलोरी मीटर में करो, जो भी टेम्परेचर चेंज है उससे यू कैन फिगर आउट द एंथैल्पी चेंज, राइट। तो ये आई थिंक लैब में उसको करना इजी है, ठीक है। डेल्टा एच थ्री भी ना आप लैब में जाके ना आप इंथैल्पी चेंज मेजर कर सकते हो। और इसको कहते हैं डायरेक्टली मेजर करना। कार्बन मोनोऑक्साइड लो, उसको ऑक्सीजन में बर्न करो एंड यू गेट कार्बन डाइऑक्साइड, ठीक है। वो जो भी हीट प्रोड्यूस हो रही है उससे पानी गर्म करो, जो भी करो, एंड यू कैन फिगर आउट द एनर्जी चेंज, उसका टेम्परेचर चेंज होगा, और यू कैन मेजर दिस इन द लैब एज वेल। अब इसके अंदर ना ये जो सेकेंड रिएक्शन है डेल्टा एच टू जो है, ये प्रॉब्ली लैब में करना बहुत मुश्किल होगा, ठीक है। उसकी मैं वैसे रीजन बता देता हूँ कि ये मैं वैसे आइडिया कह रहा हूँ कि इसलिए मुश्किल होगा कि लैब में जाके आप कार्बन को ऑक्सीजन में बर्न करो एंड यू गेट कार्बन मोनोऑक्साइड, दैट इज वेरी डिफिकल्ट। क्योंकि जब आप कार्बन को बर्न करोगे ना तो बहुत सारा उस कार्बन डाइऑक्साइड में भी कन्वर्ट हो जाएगा। सो इट वुड बी वेरी हार्ड टू टू एक्चुअली डू दिस रिएक्शन इन द लैब। मतलब उसको किस तरह कार्बन मोनोऑक्साइड पे रोकोगे, दैट इज वेरी डिफिकल्ट। वो अगर कार्बन डाइऑक्साइड बनना चाहता है वो बन जाएगा। तो ये आइडिया क्लियर है कि कुछ रिएक्शंस होते हैं वो आप लैब में या डायरेक्टली उनको मेजर करना उनकी इंथैल्पी चेंज एक्यूरेटली, इट्स वेरी डिफिकल्ट, क्योंकि वो लैब में ना वो रिएक्शन सही तरीके से होगा ही नहीं। ये बात क्लियर है सारों को?
यस सर।
ठीक है। तो वहां पे फिर हेस लॉ का फायदा आ जाता है कि अगर आपको डेल्टा H1 डेल्टा H2 पता है तो यू कैन ऑब्वियसली कैलकुलेट डेल्टा H3 एज वेल। ठीक है। एंड और इसमें ये है कि पाथ्स जो आप सिलेक्ट करते हो, वन पाथ इक्वल टू द अदर पाथ, इट कुड बी एनी पाथ, सेम मतलब सेम हेस साइकिल है, बस स्टार्टिंग पॉइंट और एंड पॉइंट सेम होना चाहिए। यू कैन गो फ्रॉम दिस पॉइंट टू दिस पॉइंट और गो फ्रॉम दिस स्टार्टिंग पॉइंट टू दिस एंड पॉइंट डायरेक्टली। तो आपकी मर्जी, यू कैन सिलेक्ट एनी पाथ। तो लेकिन बस एरो की डायरेक्शन में उल्टा जाओगे तो इंथैल्पी चेंज का साइन चेंज हो जाएगा। पाथ नंबर 2 जो होगा माइनस डेल्टा H2 और प्लस डेल्टा H1। ठीक है। तो दैट्स व्हाट पाथ नंबर 2 इज गोइंग टू बी। तो रिवर्स डायरेक्शन में जाओगे तो वो साइन जो है दैट्स गोइंग टू चेंज, और दैट्स इक्वल टू डेल्टा H3। ठीक है। तो ये आपके पास आ गया। तो ये भी क्लियर है कि यू कैन सिलेक्ट एनी ऑफ द टू पाथ्स। ठीक है। वो आपकी मर्जी है साइकिल में। और टू पाथ्स की बजाय ना आप एक पाथ भी कर सकते हो कि आप ना यू स्टार्ट एट वन पॉइंट और घूम के ना आके ना वापस उसी पॉइंट पे आ जाओ। तो तो एक ही पाथ है फिर, देन यू जस्ट हैव वन पाथ। और उसकी इंथैल्पी चेंज क्या होगी? एग्जैक्टली जीरो, क्योंकि आपने कुछ किया ही नहीं है। यू घूम के आप आए हो वापस उसी जगह पे। सो द नेट एनर्जी चेंज वुड बी एग्जैक्टली द सेम। ठीक है। तो उसका मतलब है माइनस डेल्टा H2, ठीक है, और डेल्टा H1 और माइनस डेल्टा H3। तो वो सारे को ऐड अप करो इस पाथ को, दैट शुड बी इक्वल टू जीरो। तो आप एक पाथ भी क्रिएट कर सकते हो। ठीक है। ये क्लियर है?
यस सर।
अच्छा, अब इसके जो क्वेश्चंस होंगे ना, इस पे क्वेश्चन ज्यादा आते नहीं है, लेकिन इस पे जो क्वेश्चंस होंगे वो सबसे मुश्किल होंगे, क्योंकि हेस साइकिल में अगर आपको रिएक्शंस दिए हुए ना, वो रिएक्शंस इस तरीके से दिए हुए होंगे, तो इन सारों को उस साइकिल में कन्वर्ट करना दैट इज काइंड ऑफ ट्रिकी। ठीक है। वो पजल की तरह के कौन सी इक्वेशन किधर आएगी। ठीक है। हाउ वुड द साइकिल बी मेड? तो दैट वुड बी स्लाइटली ट्रिकी। इसका एक शॉर्टकट भी है, लेकिन वो शॉर्टकट कुछ केसेस पे अप्लाई होता है, लेकिन शॉर्टकट पे हम बाद में आएंगे। द फर्स्ट थिंग इज दे कैन आस्क यू टू ड्रॉ दी हेस साइकिल। ठीक है। तो शॉर्टकट वाली चीज पे बाद में आएंगे। इसके वो क्वेश्चन हम डायरेक्ट ड्राइंग वाले क्वेश्चन ही स्टार्ट कर लेते हैं, उसी के अंदर प्रैक्टिस कर लेते हैं। अच्छा, जस्ट वन सेकेंड। अच्छा, सो जस्ट होल्ड ऑन सेकेंड। अच्छा, सो दिस वन एनर्जेटिक्स ड्राइंग हेस साइकिल नहीं है, तो दिस इज द मार्किंग स्कीम। होल्ड ऑन सेकेंड। ये अच्छा, so remember this worksheet is only about drawing the Hess cycle. ठीक है। there's another version which is the easier one. ये रेयर होते हैं, these questions are rare, but they're more difficult, kind of more difficult. अच्छा, first one, ये तो easy है। This is उसने he's just drawn a hypothetical Hess cycle and he's asking you for the enthalpy change for the transformation from U to R. ठीक है। What is you're going to start at U and you have to end up at R. So what is the enthalpy change? So the path that you're going to follow is going to be this one. ठीक है, that's your path. So that's your path. So it's what? It's minus 92. ठीक है, you're going in the other direction. And this is also in the other direction. So that sign would also change. That's going to be plus 134.
130.
So what do you get? Okay, is
Sir,
it? It is plus 42, right?
yes.
So it is plus 40. So that the first statement is true. Second one, enthalpy change for the transformation T to S is endothermic. So you are starting at T and you're going all the way to S. ठीक है, so the path that I'm going to take is probably going to be this one. So T to S, that's going to be minus 75. and the just 1 second. That's going to be minus 75. एक से ना ये चेक करो जरा, एक से मुझे देना, मैं जरा एक मैसेज कर रहा हूँ। कहाँ गई है वर्कशीट हमारी, कहाँ गई है? अच्छा दिस वन। अच्छा दिस इज minus 75 and this is, इसका भी the sign has to change, minus 92, right?
Yes, sir.
So it's not endothermic, it's negative, right? It's not endothermic. अच्छा finally the last one, enthalpy change. So this is wrong. अच्छा finally the enthalpy change for the transformation R to T, right? R, you starting at R and you're going to T. Achha, I can't go directly because I don't know what the enthalpy change is, so I have to go all the way. Achha, what is the enthalpy change in this case? R to T, right? That's minus 134, and then it's
Sir, 30
okay, plus 92, and then there is plus 75.
plus
So what do you get?
33, sir. Not negative.
Plus 33, right?
Yes,
So
sir.
so that means this is also wrong. Okay, is this clear?
Yes, sir.
Yes, sir.
Achha, next one. Now we're gonna move to the more difficult one, right? So this one. Achha, we have to uh, they've given you a bunch of data, ठीक है, and you have to figure out and you have to draw the Hess cycle yourself now, ठीक है. So remember, this is probably going to be. Remember, there are two questions in chemistry AS that are very difficult. I mean, they're normally very difficult. One is this one, the drawing Hess cycle part, and the other one is isomers. ठीक है, the isomer questions tend to be very difficult, and they take up a lot of your time. And the other one is this one. Achha, so they've given you enthalpy change of formation of cyclopropane. ठीक है, if you haven't studied organic yet, cyclopropane is the diagram that's drawn over here. It's this thing. It's three carbon cyclopropane in a cyclic manner, and each carbon will have two H's. So each carbon is going to have two H's. That is cyclopropane. So this is the enthalpy change of formation of cyclopropane. So what is the enthalpy change of formation? What is the definition? It's when 1 mole of cyclopropane is made from what? From its, क्या था? From its
Standard.
elements. ठीक है, in the standard state. So the elements are carbon solid, and the other element is H2 gas, right? And there's going to be three carbon solid, and there's going to be three H2 gas molecules, and that's going to give you cyclopropane, which is also a gas. So this enthalpy change, this path is known. This is plus 53 point. So that's plus 53.3. That is known. Then the enthalpy change of atomization of graphite. Graphite is carbon, is 717. Atomization is no longer in your course. It's in A2 now. So atomization is when you convert elements into gaseous atoms, right? So 717, right? So I'm converting carbon element into gaseous atoms. So these are my reactants, and I have to find another path to go to my products, right? So I have to create another path. So one way I can do that is I can convert the carbon into gaseous carbon atoms, and the H2 gas molecules, they remain exactly the same. I don't do anything to them. So this is what? This is atomization of graphite. That's 717 times 3. Okay, that is enthalpy of atomization of graphite. Carbon solid converted into gaseous carbon. Okay, is this clear?
Yes, sir.
Then
Jeez.
the bond enthalpy of HH is given. So what I can do is I can break the HH bond. The energy required is 436. So I've got the hydrogen molecules. I'm not going to do anything to the carbon, so carbon remains exactly the same, but I break all the HH bonds and I get six H atoms. So how many HH bonds did I break? I broke three of them. So three HH bonds got broken, and that's 436 times three. And finally, I have atoms, right? And the CH bond energy is given, and they're asking me to calculate the CC bond energy. So finally, I have atoms. What I can do is I can put those atoms together and I can form this molecule. So how many bonds do I have to make? I have to make three carbon-carbon bonds, right? And remember, bond formation is exothermic, so I'm going to give it a negative sign. So I have to make three carbon-carbon bonds, and I have to make six CH bonds. So six C and H bonds, that enthalpy change is already given. That's 410. And remember, bond formation is exothermic. So that kind of completes my Hess cycle. Okay, remember I started off with they gave me enthalpy of formation. Then they told me that atomization of carbon is this, right? Okay, it's 717 that you atomize carbon that's converted into gaseous atoms. You break the HH bond. They gave me the enthalpy change, and I was breaking three HH bonds. So I got these atoms, and I joined those atoms to form this, right? So that's the entire cycle complete. And the only thing that's missing is what they're looking for. It's the CC bond energy. Okay, so they want the CC bond energy. So I'm going to apply the Hess law, which is that one path is equal to the. So that's my one path, and that's my. So both paths are going to be equal, right? So that means 53.3 is basically equal to the rest. What is the rest? That's 717 times 3. Then it's 436 times 3. ये देख लो कि is there are you going in the opposite direction to the arrows? We not actually. अच्छा, then there is 6 times 410. अच्छा, then there's 6 times 410. And then there is 3 times C and C bond energy, right? So I need to solve this now. What I can do is I can uh, take the C to the other side. You give the other, what do you get for this? I'm going to take the CC bond to the other side, so that's going to become plus 3CC. So, and bring the 53.3 to this side, and everything gets divided by 3. I say 717 times 3, 436 times 3, minus 6 times 410, minus 53.3, and everything gets divided by 3. उसको I've just rearranged it, ठीक है? I've just made CC the subject of the equation.
333.
कितना है?
333.
नहीं, we don't have that answer. Can you try and 333? We don't have that. You देखो confirm करो, what do you get? It's अच्छा, plus the second thing is you can get things wrong on your calculator. So
सर 315.23 तो नहीं?
हाँ वही है. It's going to be it's going to be B. ठीक है, ये दोबारा ट्राई कर लो. It's going to be 315 something.
I think he didn't subtract 53.3.
Yeah,
ठीक है.
I didn't sub-
ठीक है. So ठीक है. So remember this all for just 1 mark. ठीक है, you just get after doing all of this, you just get 1 mark. So I mean, it's a pretty useless kind of question. ठीक है, so but it takes up a lot of time. There's a shorter way of doing this, but that only applies. It doesn't apply to this one. So there's some questions shorter पे बाद में आते हैं. Shorter is it it has to meet certain conditions. So is this one clear? This entire question.
Yes, sir.
ठीक है.
Yes, sir.
As the next one, it's a very similar question. Uh, He's saying Hess law can be used to calculate the CH bond energy in methane, right? So enthalpy of atomization. So remember, atomization is no longer in your course, but atomization is when you convert an element into its gaseous atoms, right? So enthalpy of formation, enthalpy of combustion. Which data values are needed in order to perform the calculation? So, and he's talking about methane, right? So we can do something similar that we did over here. You can start off with enthalpy of formation. Enthalpy of formation is when elements get together to form 1 mole of methane, right? So you need delta HF, and you can then create a cycle, which is that you can atomize carbon, turn it into gaseous atoms. So you need the enthalpy of atomization of carbon. Then you can break the HH bonds. So carbon has already been atomized, and you can break the HH bonds. So that's going to give you 4H gaseous atoms, right? And all of them can get together to form 4 CH bonds. ठीक है, it's a very similar equation, similar cycle that we made just earlier. So enthalpy of formation, elements turning into the product. You break the bonds, carbon turns into atoms, hydrogen turns into atoms, and then those atoms get together and they form bonds. And this will have a minus sign. And he's asking which data values are needed to figure out the CH bond energy, right? So you need an enthalpy of formation, you need atomization of carbon, and you need the HH bond energy, which which data is needed.
सर ए नहीं होगा.
ठीक है, so it's going to be A. Okay, this is atomization of H because the H element turned into gaseous H atoms, right? So enthalpy of atomization of H, enthalpy of atomization of carbon, and enthalpy of formation of CH4.
सी बॉन्ड एनर्जी एंथैल्पी ऑफ एटमाइजेशन तो नहीं हो सकती ना.
हो सकती है.
हो सकती है.
Okay, element has to turn into gaseous atoms, right? So if you have H2 gas, right, that's the element, and you turn it into H gaseous atoms, right? So you're basically breaking bonds, right? ठीक है. तो बस फिलहाल don't go into atomization too much because it's in A2 now. You have a lot of past paper questions that have atomization in it, ठीक है? But otherwise, is this clear?
Yes, sir.
अच्छा, remember वो मैं क्योंकि bond energy की बात हुई थी ना, so remember this that you can always use bond energies if everyone is gaseous. ठीक है? Bond energies are defined for gaseous molecules. So if you have any reaction and all of them are gaseous, this is case में you can't use bond energy. The first one, enthalpy of formation cannot be used. You can't use bond energies क्योंकि bond energies are not defined for solids. तो ये clear है कि वो atomization or combustion or anything. If every one of them is gaseous, then you can calculate that using bond energy as well. Anam, clear?
जी सर.
I said this one. Okay. Now, in this question, they're asking for you to calculate what? He's saying the enthalpy change of formation of hydrated calcium ions is the enthalpy change of the following reaction. What is the enthalpy change of hydrated calcium ions? So this one, right? They're asking you to figure out what this is. I'm just going to rewrite this. Calcium solid plus aqueous minus 2 electrons, and it's forming calcium 2 plus aqueous. So you're supposed to figure out this one. Now, what you can do is you can create another path. So what you can do is you can go from this point. You can start from this point and you have to reach the other point in steps. So what they've given you is they've given you calcium solid turning into calcium gas, and that's 177. So I have calcium solid. I can turn that into calcium gas. Everything remains exactly the same. The only thing I changed was calcium solid turning into calcium gas. So what is the enthalpy change for doing that? That's 177, right? Is this clear?
Yes, sir.
So on the other side, I have calcium ions gaseous plus aqueous turning into calcium 2 plus aqueous. So where can I fit this? Uh, because I don't have any of them. I don't have calcium ions gaseous over here, so I don't have calcium 2 plus, there's calcium 2 plus aqueous over here. So they're getting formed. So what I can do is I can form them. That calcium ions gaseous plus aqueous turning into calcium 2 plus. So calcium ions gaseous plus aqueous, and they're turning into calcium 2 plus aqueous. Okay, so this path is exactly this path. That's minus 1565. You be clear? Is this clear?
Yes, sir.
But the problem is my hair cycle is not complete because there's something that's missing in the middle. Okay, what is this? Can anyone, and this data is not given over here. I mean, they've asked me to look in the data booklet as well. Tell the first thing, can somebody explain what's happening over here in this path only? When you go from this point to this point, what exactly happens?
Loss of electron.
Okay, so the aqueous is not doing anything. Okay, the aqueous is not, I mean, it's not really doing anything. It was there, it was still over here. The only thing that changed was that you have calcium gas and you're removing two electrons from it and it's turning into calcium 2 plus ions. What is that called when you remove electrons from an atom?
Ionization.
Okay, that's known as the ionization energy. So you're ionizing a gaseous atom and it's the first plus the second ionization energy. Okay, is this clear?
Yes, sir.
That it's the first plus second ionization energy. And that is going to be given in the data booklet somewhere. अब जो क्वेश्चन होगा ना उसके अंदर it's going to be printed next to it. ठीक है. So this is where the first and second ionization energies were given. Uh, so it's 590 and 1150. That's what these values are. So one of them is 590 and the other one is 1150. So अब आ जाओ question mark. We were supposed to figure out the question mark. The question mark is one path is equal to the other path. So the other path is what? 177 plus 590 plus 1150 and minus 1565. That's your answer. ठीक है, one path, this question mark is basically equal to this entire path. क्या
सर मेरा डी आ
डी है?
मेरा तो डी आ रहा
352. ठीक है. अच्छा, फिर से I'm again repeating कि these questions are not very frequent and these questions are very difficult. ठीक है. Easy, we will come to the easier ones. अभी assume कि even if you look at the examiner report, barely 20% are able to actually answer this in the actual exam. I said, but is this clear? Question otherwise, is this clear?
Yes, sir.
जी sir.
So next one again, there's another one, okay, Hess cycle. Uh, Now what you're given is he's asking for the enthalpy change of this reaction, okay? So you have to go from this point and you have to make the products. Okay, you don't know what the direct path is, so you're gonna try and create the indirect path. And there are three reactions given. The first one, carbon monoxide, in the first reaction, carbon monoxide turns into carbon dioxide, and that's minus 283. So I have carbon monoxide over here. I'm going to turn it into carbon dioxide. So carbon monoxide turns into carbon dioxide gas. Nothing happens to H2O. H2O remains a. So that's the first equation. Carbon monoxide turns into carbon dioxide gas. So only that happened. Carbon monoxide turned into carbon dioxide, and the enthalpy change for that is minus 283. Is this clear? Or clear?
Yes, sir.
जी
अच्छा फिर next one. H2 turns into H2O liquid. So I have H2 over here. So that H2 turns into अच्छा it turns into H2O liquid. So nothing happens to carbon dioxide, remains a gas, and the H2 over here turns into H2O liquid. And the enthalpy change for that is minus 286. So this path is minus 286. So then the last one. H2O gas turns into H2O liquid. So that is happening over here. If you focus on if I try to complete the Hess cycle. So what happened in this path? Nothing happened to carbon dioxide. Carbon dioxide was a gas, or उस side पे भी ना carbon dioxide is still a gas. So nothing really happened to it. The only thing that changed over here in this path, ये जो green वाला arrow है, the only thing that changed was H2O liquid, and it eventually changed into H2O gas, right? So H2O liquid, ये उल्टा जा रहा है. H2O liquid turning into H2O gas. So that's going to be plus 44. I'm going in the opposite direction. ठीक है, the arrow is pointing in the other way around. ठीक है, H2O liquid turning into H2O gas. So that's, you have to go from this to this. So that's minus, plus, it becomes plus 44. So is this clear? The cycle is now complete. Clear?
Yes.
Yes, sir.
अच्छा, direction क्या होगी? You have to go in this direction, right? Go from reactants to products. So it's going to be minus 286, and then it's going to be plus 44. And this last arrow, you have to go in the opposite direction, so that's going to become plus 283. So what do you get?
I'm getting C plus 41.
ठीक है, so this one is going to be C, which is plus 41.
So ये जो second equation है, it says H2 gas plus half O2 gas. तो
अच्छा वो
half O2
उसको what you can do is you can, because if you include O2, that makes the whole cycle more complicated. ठीक है, so it's better you just focus on the fact that H2 turns into H2 liquid. That's it. I mean, if I want to be more exact, ठीक है, so यहाँ पे फिर क्या होगा? It's going to be carbon monoxide. It needs half O2, right? So you would have to add half O2, right? और H2 को कितना चाहिए O2? It also needs half O2, right? I mean, if you want to burn H2, it also needs half O2. But the thing is, the O2 is not making a difference. Okay, in this equation, it doesn't make a difference because O2 is not doing anything in this equation. इस वाले path में O2 is not doing anything. Half O2 यहाँ पे भी है and half O2 is on the other side as well. So basically, it doesn't really do anything. ठीक है? So is this clear? You can ignore O2. वो बस easy होगा. Carbon monoxide turns into carbon dioxide. H2 turns into H2O liquid. Anam, clear है?
जी sir.
So next one. So what is the enthalpy change of formation of enthalpy change of formation of ICl3 solid? वो क्या होता है? Formation क्या होता है? It's when 1 mole of ICl3 has to be formed, and it is a solid from its क्या elements. ठीक है, the elements are what? Iodine solid and Cl2 gas. And in enthalpy of formation, it has to be 1 mole of ICl3. So this is going to be half. And usko, if I want to keep that 1 mole, this would be 3 by 2, right? So I'm looking for this thing. I'm looking for this enthalpy change. ठीक है? Is this clear? Formation of ICl3. Clear है?
Yes.
जी sir.
अच्छा, now the issue is कि I don't like to deal with fractions. ठीक है? Fractions can be balancing in fractions can be problematic. So what we can do is to just to simplify things is I can multiply the whole thing by 2. So the enthalpy change would double, right? I will no longer have half. I will no longer have 3 by 2. That's going to become 3. And this will become 2 ICl3 solid. Okay? I mean, the only reason I multiplied it by 2 was I don't like fractions. Okay, clear है? वो बस, so instead of finding x, I'm trying to find out 2x. Right? Is this clear?
Yes, sir.
वरना उस तरह भी
Okay.
वरना उस तरह भी कर सकते थे, लेकिन वो बस fractions में things just become more complicated. अच्छा, so we're looking for this thing. So the first thing, iodine solid turns into iodine gas. So I have iodine solid, and I'm going to turn it into iodine gas. And I'm not doing anything to Cl2, so that remains exactly the same. This value is what? Plus 38. Okay, so iodine solid turned into iodine gas. So next one is iodine gas reacts with Cl2 gas to form 2ICl3 solid, which is exactly this path. Iodine gas reacts with 3Cl2 gas to form 2ICl3 solid. That's exactly this. It's minus 214. Okay, is this clear? The paths are complete. So one path is basically equal to your other paths. That means 2x is basically equal to plus 38 and minus 214. And I'm looking for x, so basically it's going to be divided by 2. So what do we get?
Minus 88.
Okay, this comes out to be minus 88, which is B. Okay, is this clear?
Yes.
Yes, sir.
Yes.
अच्छा, ये भी this one is very very similar. ठीक है. um, ये क्वेश्चन है, लेकिन इट्स रिलेटेड टू एमसी डेल्टा टी एज वेल, सो वील डू दैट लेटर. अच्छा, चलो, we'll so we've done enough. You don't have a lot of questions on these. ठीक है? There's just in total 6-7 questions in like 15 years on drawing the Hess cycle itself or drawing the complicated Hess cycle. अच्छा, अब वो है कि मूविंग ऑन. ठीक है? That's ठीक है. These are the questions solved. अच्छा, now the Hess cycle formula, I'll just briefly tell you what the formulas are. There are two formulas for where you can, instead of drawing the Hess cycle, you don't have to. I mean, they're even going to ask you to draw the Hess cycle in this case as well, but in most cases, you don't really need you don't need to draw the Hess cycle. So I'm going to explain the formulas in the next class. I'll just talk about the formulas, which is that the formulas are conditional. They have a condition attached to them, which is if you have a reaction and they give you the enthalpies of formation of the reactants and also the enthalpies of formation of the products, then the enthalpy of that particular reaction, you don't have to draw this entire cycle. You can get the answer directly. So if enthalpies of formation of the reactants are given and enthalpies of formation of the products are given, the simple formula is that the enthalpy change of that particular reaction is it's the enthalpies of formation of the products minus the enthalpies of formation of the reactants. That's it. So you can directly apply that formula and you can get the answer. You don't have to draw this entire cycle. ठीक है? ये clear है?
Yes, sir.
And let me just focus on this. If you're given the enthalpies of formation, right? What that basically means is that these compounds are getting formed from its elements, right? So these are the elements. The elements are carbon, hydrogen, and oxygen. They're going to get together and they're going to form these compounds. So that is enthalpy of formation, right? Uh, and the same over here. If the enthalpies of formation of these are given, then these same elements are going to get together and they're going to form these compounds. So since you're forming two carbon dioxide, so that's two times the enthalpy of formation of carbon dioxide, three times the enthalpy of formation of water because you're forming three water molecules. Now, since you have to go from reactants to products, you have to go in this direction. So your reactant side, the arrow has to change direction. So the sign will change. It will become minus, right? And these will remain positive, right? So that's why it is the वो जो reactant वाली enthalpy of formation है, that becomes negative. ठीक है? So you can still be asked to draw the Hess cycle. So just remember, with enthalpies of formation, the Hess cycle is pretty simple. You just write elements. The elements form the reactants. The elements also form the products, and that completes your Hess cycle. ठीक है? For any equation. SO2 plus O2 reacting and then forming SO3, enthalpies of formation are given. You write the elements. This is the enthalpy of formation of the reactants. The elements turning into the reactants. The same elements forming the product, so that's the enthalpy of formation of the products. Or without the S cycle, it's simple. It's just this formula, which is product minus reactants. Okay. So we're gonna do questions on that. It's gonna basically you just have to use this formula most of the time. Okay. So we'll continue with this tomorrow. Okay.
ओके सर।
ओके सर।
Okay, sir.
हाँ, मार्किंग स्कीम भी भेज देंगे इसकी। आई डोंट थिंक आपने भेजी थी। आई थिंक आपने सिर्फ वर्कशीट भेजी थी।
अच्छा मैं वो भेज देता हूँ मार्केट स्कीम्स भेज देता हूँ ठीक है सॉल्व भेज
ओके।
देता हूँ ठीक है ओके देन टेक केयर एवरीवन
No,
अब
अल्लाह हाफिज़।